It's a mesh analysis. We need to assign the mesh current, right? So the first loop, I'm going to call it, this is I sub 1. Second loop, this is I sub 2. I can assign I sub 3 here. But actually the I sub 3, there is a current going upward the last loop. So instead of assigning another extra unknown variable as an I sub 3, I'm going to say, hey, we have current source provide the current in the outer loop going this way, and that is 2 milli. It's a number. That way now we have two equations and two unknowns. Those are the two. What are those two unknowns? I sub 1 and I sub 2. So now first thing, we want to do KVL at I sub 1. So following this direction, current we assign going this way. So entering the negative terminal of the 6 volts. So I would say negative 6 plus 2K I sub 1 plus 4K. What's the current? Go through in 4K resistor. I sub 1 minus I sub 2. Good. I sub 1 minus I sub 2. And this equals to 0. Done. And then when we do KVL at I sub 2, we're going to start from the top. 4K times I sub 2, 8K. Watch it here. What's the current go through 8K now? Plus, because they're the same direction going downward. Good. So I sub 2 plus 2 milli. And then left side of the 4K, 4K. This time we need to say I sub 2 minus I sub 1 equals to 0. Notice this direction of the current. I mean, we don't know where's the higher potential or lower potential. I mean, we don't know the voltage across here is a positive. We need to put positive or negative, negative, positive or negative. We don't know. So we assign the random direction. Therefore, all of this, except for the 6 volts, this current I sub 1 entering to the negative terminal of the 6 volts, we need to write negative 6, right? But all other terms, V equals to IR terms, I times R, I times R, I times R, I times of R, I times R. They are all positive. So we'll take care of that later. If I1 is greater than I2, this guy is going to be positive voltage. If I sub 1 is greater than I sub 2, then this will give us the negative value. And in front of the 4K, we have to flip the polarity to positive or negative, negative to positive. We need to change it. So while you are doing mesh analysis, I times R term, they are all positive. Please note on that, because when you have a quiz and exam, you may confuse, hey, direction of the current is going this way, and this one is opposite way, so maybe I need to put minus 4K times I sub 2. No, for the mesh analysis, always I times R is going to be positive. So now we have two equations and two unknown. We need to just simplify that. I sub 1 term, 2K plus 4K. We have 6K I sub 1, negative 4K I sub 2 equals to 6. That's the first equation. From the second equation, we have I sub 1 is negative 4K I sub 1. I sub 2, 4K, 8K, 12, 16K I sub 2 equals 8K times 2 milli. So K and milli will give us 1. And 8 times 2, 16. Move it over, negative 16. Now you use your calculator. We have a 2 equation and 2 unknown. You plug in coefficients, you end up getting I sub 1 is 2 over 5 milli. I sub 2 is negative 9 over 10. Now what is V naught? Equals 4K times I sub 2, negative 9 over 10 milli. So that is negative 3.6 volts. So you are given positive and negative, but it's a negative 3.6, so its polarity actually the opposite. So let's work on the problem 3.2.13. Circuit is given. We need to use mesh analysis to find I sub 0 right there. We need to assign the current here, I sub 1. But for here, since this current source is given, that's the outer loop, so we can just call it this current as a 4 milli. So we're going to do this, and this is 2 milli. If the current source is in the middle, then we are in trouble. That's the super mesh. But current source is outer loop. Then simply we can assign the direction of the current is the same way that you see in the circuit, and then use the number so that we don't have to assign two additional variables in the problem. If this is the case, we just need to do only one equation for the mesh current using mesh current I sub 1, and we should be able to solve I sub 1, and then we are done. So KVL at I sub 1, I'm going to start from here, 6 volts. This I sub 1 entering the negative terminal, therefore I'm going to write negative 6 plus 2K I sub 1, we are using I sub 1, therefore I sub 1 has to be the positive, KVL using I sub 1. I sub 1 is a positive. And then the opposite direction is a 4 milli. And then 1K at the top plus 1K, our I sub 1 minus I sub 1 in going to the right, but 2 milli at the top to the left. So they are opposite. So we need to subtract 2 milli equals to 0. Yeah, I mean I naught is something we're going to find out later once we know what is I sub 1. We can do KCL at this node, then we can find that out. But I sub 0 is not the mesh current. That's the current go through this 2 kilo ohm. We'll eventually do this. KCL at A, then this is entering, this is entering, this is leaving. So entering is I sub 1, entering is I sub 0 equals to leaving as a 4 milli. We end up getting two equations to unknown. Actually, it's going to be the same. So now we have here 2K I sub 1 plus 1K I sub 1, so it's 3K I sub 1 equals, move it over everything to the other side, positive 6. This is a positive 8, and this is positive 2. 3K I sub 1 equals 16. So I sub 1 is 16 over 3 milliamp. And then use this guy, I sub 0 equals to 4 milli minus I sub 1, 4 milli minus 16 over 3 milli, 12 over 3 minus 16 over 3, negative 4 over 3 milliamp. So let's work on the problem 3.2.19. Now we need to assign the mesh current first. So I'm going to have I sub 1 here, and then I sub 2 here, and then I sub 3 here. Okay, now what we do? KVL using I sub 1. Then I sub 1 entering the positive terminal of the voltage, plus 6 plus 6K. For this 6K, our reference direction is I sub 1, right? Therefore, the current go through 6K is going to be what? Thank you. And then we need to write IR, but we have a current source. We don't have I, we don't have a R, we don't have voltage. So when we do the super node, we have a voltage source between two non-reference nodes, right? That's the problem. For the super mesh, we have a current source between two mesh current. We cannot do KVL because of this guy. So we cannot do this. So what we need to do, we need to kind of hiding this guy. We're going to call it super mesh. It's there, but we pretend it's not there. So when we do KVL this time, it's there, but we pretend it's not there. That means we have super mesh going around this outer loop. Make sense? Yeah, I'm going to say that again. It's a super mesh. All those superheroes, it's there, but we don't see it. We pretend it's not there. If it's not there, then we have a current going outer loop. Make sense? And I'm going to call that super mesh current. It's going to be this blue. I'm not going to name this guy the super mesh current, but we need to just follow that KVL at super mesh. So starting from 6 volts, positive 6 plus 6K, we have I sub 1 minus I sub 3. So this 6K is this 6K, blue 6K, and this guy is purple 6K, purple 6K, blue 6K, plus now blue 6K, this time where the super mesh current is going this direction, right? So we have 6K times I sub 2, and then opposite direction at the top, minus I sub 3, and plus 6K times I sub 2 equals to 0. Then we didn't use this upper loop, So we need to do KVL. Before we do that, let's simplify this. So I sub 1, we have 6K I sub 1 plus 12K I sub 2 minus 12K I sub 3 equals negative 6. We have I sub 1, I sub 2, I sub 3. So we should have 3 equations. Now when we do KVL at I sub 3, we have top 6K times I sub 3 plus blue 6K. Now our reference current is I sub 3. So I sub 3 minus, for blue, opposite direction is I sub 2 plus purple 6K. Our reference current is I sub 3 minus the opposite direction we have at the bottom of the 6K is I sub 1. That equals to 0. So if we simplify I sub 1, negative 6K I sub 1, negative 6K I sub 2, 666 plus 18K I sub 3 equals to 0. Now we have 2 equations. We need to have one more. Where? How? In these 2 equations, we didn't use this guy. So we have to use this. So your option is you need to do KCL either bottom or here. Really doesn't matter. I'm going to do here is A. And then we want to do KCL at node A. Then entering. I sub 2 is entering. 5 milli is leaving. I sub 1 is leaving. So entering I sub 2 equals leaving 5 milli plus I sub 1. So if I move I sub 1 to the other side, minus I sub 1 plus I sub 2 equals 5 milli. Then if you use your calculator, we have I sub 1 equals negative 1.4 milliamp. I sub 2 negative 4.6 milliamp. I sub 3 equals 0.4 milliamp. And then I sub 0 equals to I sub 3. I'm sorry, I use different directions. Sorry, I use this is I sub 1. So I sub 1, this should be I sub 3. So this should be I sub 1. So this should be I sub 2. Yeah, I naught is outside with the 6K. This mesh current I sub 2 is not the current go through 6K because there is I sub 2 and I sub 3 in the opposites. However, this outer 6K, that's the only one current go through, which is I sub 2. Yeah, no reason. Either, as I said, you can do here or here. But if you want to do in here, it's not clear. This 5 milli is entering is clear, but here, going through 6K, is I sub 2 minus I sub 3. So your equation is much more complicated than this guy. It's clear we know this current, and this current.